Question 7 is question about the preparation of 233-trimethyl-1-ene. Okay, we're going from alcohol to an alkene plus water. Figure 3 shows the apparatus used. Heat and alcohol plus anti-bumping granules, thermometer, water in, condenser, yep. And it says the distillate is collected in the ratio 77 to 82 degrees Celsius. Explain why the water should enter the condenser at the bottom and not at the top. That's what's asking us. So the water should enter the condenser at the bottom because the idea of ensuring the condenser fills with water. Ensuring the condenser fills with water. Condenser is cooler / ensuring more vapor condenses. Now for this practical, the alcohol practical, there's only a certain amount of questions they can ask you about, labeling it, describing mistakes with it, which I've seen a 6 marker on, labeling it as well, yeah, that's just said that. And this one, explaining how water should enter condenser at bottom and not the top. Ensuring the condenser fills with water, ensures the condenser is cooler, ensuring more vapor condenses. And 7.2, name a complete mechanism for this reaction. As soon as you see this, oxygen or pair of electrons bonds to H plus is obviously going to be elimination. Going from alcohol to an alkene, elimination of water from alcohols, elimination. And what happens is you've got your CH3, CH3. I don't think you need to draw out the CH3s. If you do, well then, in the exam I probably would, just to be sure that is correct, be safe. And it is 4 marks, so 4 minutes, right? And if you're hopefully by the time I do my A-levels, inshallah, by the time I do my A-levels, and by the time you guys do your A-levels, we should be extremely confident with these mechanisms, so we can probably do them in like 2 minutes. So then the rest of 2 minutes can be just drawing out the CH3s. So CH3, C, CH3, CH3, CH, CH3, CH2, and the oxygens. Now, what happens is now the oxygen's positive, so you go OH, OH2 you could say as well, but I like to draw it out, and the oxygen's positive. It's bonded to H plus. And now what happens is it goes from middle of CH2 to the oxygen, not to the positive charge, to the oxygen. And then what happens is now you got CH3C, CH3, CH3, CH, CH3, CH2, but now the carbon's positive, and now the carbon positive wants to reform the double bond. Now which way does it reform the double bond? What's going to form it from here where this hydrogen is? Because remember, we're minusing a H plus as well from this mechanism, but if we try to do it from here, well, CH3, so it wouldn't work because it would be a CC, carbon-carbon bond. So it's from here to the middle of the CCH2 bond, the carbon positive, and we minus H plus, and in this case, yeah, we minus H plus, and we minus the water molecule because it leaves the carbon positive. And then you can show, but it doesn't need to show the final product. CH3, CH2, CH3, CH, CH. It would be C here. This hydrogen will leave CH3, and it also will have a double bond there as well. 7.3. In a similar experiment, 12 centimeters cubed of this produces this much of 233 trimethylbutanene. Calculate percentage yield. So first thing I can spot is we've got volume and we've got the density. Well, we can find out mass because we know density is mass of volume. Therefore, mass is density times by volume. Mass going to be density 0.818. Let's double check all the same thing. 233 trimethylbutanol, 233 trimethylbutanol. So the same thing times by the volume 12. 9.816 grams. They're both in centimeters cubed, so it's fine. Now we can find out the moles. So the moles is going to be the mass 9.816 divided by the MR 116.0. 116.0. That will give me 0.0846 moles. And now what we can find out is the theoretical yield of 233 trimethylbutanene, because we know this is the actual yield, how much it actually produces, 6.12. We want the theoretical yield, because percentage yield is actual yield over theoretical yield divided by 100. To find out theoretical yield, first we need to find out the MR of 233-trimethylbutanene. And does it 233-trimethylbutanene? So yeah, it does actually give us the displayed formula. So you just go to periodic table, put in all these values in the calculator, and work out the MR. But if you do that, you get the MR of alkene. Let's label it MR of alkene equals 98.0. Now we can find out the moles of the alkene. Now we can find out the theoretical yield, so the mass. Moles and mass of MR. Mass is going to be the moles, 1 to 1 molar ratio, so 0.0846 times by 98.0. That will give me 8.29 grams, and this is a theoretical yield. Just label it for the examiner to know. And that's 8.29 grams. So the percentage is going to be the actual yield, 6.12, divided by theoretical yield, 8.29, and because it's a percentage, we can times by 100. And that will give me 73.8%. Does it say 21? No, it just says calculate percentage yield. So we can leave it to 1 decimal place, 2 decimal place, 2 significant figures, 3 significant figures, it doesn't really matter. 73.8% is your final answer. And that is the end of question 7.